H.G. Matthews, and it started because I decided that I wanted a retirement project, which was to make a product instead of having to be bossed about by architects and engineers. And then, so I thought, when I was 50, I went on a stove making course in Slovakia. And that was all about making stoves with separate masonry elements, with bricks and with factory bricks. And I thought about doing that, and then for various reasons, I kind of thought maybe it would be interesting to see if you could cast a stove in layers. So this is 7 layers, 1, 2, 3, 4, 5, 6, 7. But inside there's different geometry. So this is like the cutaway drawing of that stove. So at the bottom here, you've got the ash box, and I should just say that this is a Mark III, where I cast I cast each layer in 2 with a joint front and back, so that when it heats up and expands and contracts, there's a natural crack already made. Now I've actually abandoned that, but so this is just a demo thing to say what can be done. So this is the ash box here, and above the ash box you've got some sort of grid, and you have your fire there, and you make your fire as hot as you can possibly make it. You want 700 degrees, 800 degrees. You want it as hot and as fast as you can possibly make it. And so you can see with this one that it's a bigger fire hole at that level. There's 2 more layers above the ash box layer. But now you've got the fire coming up, and it's coming through this hole here in the center of the stove. And what it's doing is it's losing heat all the time into the clay. And part of what I was trying to work out is how much heat is it losing, what's actually happening. Then it hits the roof, okay, and the roof is the roof. It doesn't come out of the roof. You can look in here. There's a kind of an indent in the roof, which pushes the smoke now sideways because it can't go back down. It's being chased by the heat below it, and it then gets pushed down all of these holes, and it gets pushed all the way down, and then there's a connection from the back there and the back there that pushes it to the back of the stove, and then the gases come up out the back. And the point about this stove is that we've got masses and masses of houses with fireplaces, and I thought you could just put it in front of a fireplace because the gas would sit into the fireplace and go up the existing chimney. Okay, that was kind of the idea. So this is HG clay and crushed fired brick, about 60% crushed fired brick, and there's a little bit of fibre in it. And then when I'm casting these sections, particularly, you can see this is jute. So you're just trying to control the shrinkage so that it's not cracking as it dries. As soon as it's dried, that's redundant. And then just to say it, on the back side, there's a whole lot of holes where I've put thermocouples to see what's happening. And I've got a thermocouple that comes into the back of the stove here that's measuring the hot gases, so I know it's at 750, say. And then I've got another one right next to it, but it's 20 millimeters back from that outside face. Okay, so it's just measuring the temperature change in the clay. That's never gone over 75. Okay, and the point is that you're filling your wood box, you're burning it once, and then it goes out, and then all of that heat that's gone into the clay slowly comes out and radiates out for the next about between 10 and 12 hours. Okay, so you're just putting in 6 or 7 kilos of fuel, and then you're good for quite a reasonable amount of time. And then I've got another thermocouple where the gases are coming out of the back, and that's about 100. So you've got a shift from 600, 700, 800 here to 100 at the back. So you know that heat, even though there's this step down from 700 to 70 into the clay, but it is going in. And the more surface area you've got that it can touch as it goes along, is the better. And the reason that I haven't retired and started my retirement project is that I'm still stuck on emissions, because it's a really complicated thing. And I've got a flue gas analyzer, and I've been measuring the particulates and the all that stuff. And so I'm looking for a physicist who can take me to the next stage. So that's one way of looking at mass and heat. Okay? Thanks.